Right now, as you're watching this, your body is being protected by a thin blanket of atmosphere from temperatures so cold they'd freeze your blood solid in less than 3 seconds. Just 62 miles above your head, space doesn't care about your survival. It doesn't care about anything. Most people think they understand cold. They've felt winter mornings that bite at their skin. They've seen documentaries about Antarctica, where researchers bundle up in layers of insulation. They think that's as cold as it gets. They're dead wrong. Space operates by different rules. Rules that'd kill you before you even had time to scream. Here's what NASA doesn't tell you in their glossy press releases. Every astronaut who's ever left Earth's atmosphere has been one thin wall away from experiencing cold so absolute it'd turn their body into a frozen statue in minutes. And that's just the beginning. Because as we travel further from Earth, deeper into the cosmic void, the temperatures don't just drop. They plummet into realms that shouldn't be possible, places where the very concept of heat becomes meaningless. And somewhere out there, in the darkest corners of our universe, exists a cold so complete that atoms themselves nearly stop moving. You need to see how deep this rabbit hole goes. Subscribe to the channel for more space videos, because what you're about to discover will change how you think about the universe forever. Number 1. The killing cold right above your head. Picture the International Space Station, that gleaming symbol of human achievement orbiting 250 miles above Earth. The astronauts inside are comfortable, working in shirt sleeves, floating through corridors that feel almost normal. But step outside. The moment an astronaut exits the airlock for a spacewalk, they're surrounded by temperatures that hover around minus 250 degrees Fahrenheit. That's more than 200 degrees colder than the coldest temperature ever recorded on Earth. Here's the thing that keeps NASA engineers awake at night. Those spacesuits aren't just clothing, they're survival pods. Because in the shadow of Earth, where the sun's rays can't reach, space becomes a freezer that makes Antarctica look tropical. Commander Chris Hadfield once described it during a spacewalk. One side of his body, facing the sun, was being heated to over 200 degrees Fahrenheit. The other side, facing away, was being frozen at minus 250. His spacesuit was the only thing standing between him and temperatures that swing by 450 degrees, depending on which way he turned. But that's nothing compared to what happens when you leave Earth's neighborhood entirely. Number 2. The void between worlds. Mars sits roughly 140 million miles from the Sun on average. When NASA's Perseverance rover landed there in 2021, it immediately began recording temperatures that'd make Earth's polar regions seem like a tropical vacation. The average temperature on Mars hovers around minus 80 degrees Fahrenheit. But here's where it gets terrifying. During Martian winter, at the poles, temperatures plummet to minus 195 degrees Fahrenheit. That's cold enough to freeze carbon dioxide out of the atmosphere. Not water, carbon dioxide. The stuff you breathe out turns into solid dry ice and falls from the sky like snow. But even Mars, frozen as it is, sits relatively close to our sun. The further you travel from that nuclear furnace, keeping our solar system warm, the more you realize how utterly hostile space becomes. Jupiter, that massive gas giant, sits in a realm where the sun appears as nothing more than a bright star. The temperature there averages minus 234 degrees Fahrenheit. The moons of Jupiter exist in a permanent deep freeze that'd instantly kill any Earth life. Yet Jupiter is still within our solar system, still relatively close to home.
What happens when you leave the sun's influence entirely? Number 3. The space between stars. In 1977, NASA launched Voyager 1 with a simple mission: leave the solar system and keep going. In 2012, 35 years later, it finally crossed into interstellar space. The data it sent back revealed a cold so profound it defies human understanding. Interstellar space, the vast emptiness between star systems, maintains a temperature of roughly minus 450 degrees Fahrenheit. That's just a few degrees above absolute zero, the point where atomic motion nearly stops entirely. Here's what this actually means. If you could somehow survive in interstellar space for just 1 second, the moisture in your eyes would freeze solid before you could blink. Your blood would begin crystallizing in your veins. The air in your lungs would become solid chunks of frozen nitrogen and oxygen. But even this cosmic deep freeze isn't the coldest place in the universe, because in the darkest regions of space, in places where no star has ever shone, temperatures drop even further into realms that seem to defy the laws of physics. Number 4, the cosmic deep freeze. The Bode's Void is a region of space so empty, it's been called the Great Nothing. It's a sphere roughly 330 million light-years in diameter, where almost no galaxies exist, just emptiness. Vast, unimaginable emptiness. Here, with no stars to provide even the faintest warmth, temperatures approach absolute zero, minus 459.67 degrees Fahrenheit, just a fraction of a degree above the theoretical limit where all atomic motion stops. But scientists have found something even colder. The cosmic microwave background, the leftover radiation from the Big Bang itself, maintains a temperature of minus 454.76 degrees Fahrenheit throughout most of the universe. But in the deepest voids, in regions called cosmic supervoids, even this faint background radiation gets stretched and cooled. These are the coldest natural places in the universe. Regions where space itself has been expanding so rapidly that even the echo of creation's fire has been frozen into near silence. Yet here's the most mind-bending part. The coldest place in the known universe isn't some distant cosmic void. It's right here in our solar system. Number 5, colder than the universe itself. Permanently shadowed regions at the lunar poles, craters where sunlight hasn't touched the surface for billions of years, maintain temperatures of minus 414 degrees Fahrenheit. That's colder than Pluto, colder than the surface of Neptune. In some measurements, these lunar craters are colder than the average temperature of deep space itself. NASA's Lunar Reconnaissance Orbiter found this in 2009, and it changed everything we thought we knew about cold. These aren't just craters. They're natural freezers that have been running continuously since the solar system formed 4.5 billion years ago. Water ice in these craters exists in a state so frozen, so preserved, that it might contain chemical signatures from the birth of the solar system. Frozen time capsules maintaining temperatures that rival the deepest cosmic voids. But even this isn't the ultimate cold, because in laboratories here on Earth, scientists have achieved temperatures that make all of these cosmic deep freezes look warm by comparison. They've created conditions colder than anywhere in the natural universe, places where the very concept of temperature begins to break down. And that should terrify you. Why? Because it means the universe itself, for all its hostile frozen voids and lightless depths, still maintains a kind of warmth compared to what's theoretically possible. The cosmic background radiation, that faint whisper of the Big Bang, is still providing just enough energy to keep the universe from reaching true, absolute zero. What happens when that finally fades? When the universe expands so far that even this last remnant of creation's fire goes dark. We're living in the warm period of cosmic history, the brief few billion years when stars still burn and planets can harbor life. But space is patient. It's been practicing this cold for 14 billion years, and it's only getting better at it. Every breath you take, every moment you exist, happens in defiance of a universe that wants to freeze you solid. Space isn't just cold, it's waiting. Subscribe to the channel for more space videos.